All right, I'm gonna go ahead and get started with the material today. I want to use this time to kind of piece together and finish up with what we've been working on as far as polynomials are concerned. All right, so some of the things that we looked at here is making sure we know how to find things like the degree of a polynomial, how to find something like the domain of a polynomial, right? From the degree, you should be able to tell me the number of turning points that a polynomial can have at most. Okay. You should be able to know whether or not there's a function has a reflection, which polynomials are things that we need to have in place. All right. So what I have here is a few different polynomials. As you'll see, I have some different forms involved as far as the polynomials are concerned as well. So we do want to make sure we're comfortable with each of the ways it can be written. With that said, let's jump into it. So when we look at f of x here, what type of polynomial is this? What's the specific name we give this one? All right. So we need to make sure to recognize this one is quadratic. All right. Recognizing what you're working with is important. With that said, there's some things that we can take from this. So if I go copy them down instead of writing them out, we can still list this. Now with quadratics, we didn't necessarily list this because we're going to have some other things to talk about. But make sure you see here that the degrees of a quadratic is 2. That's why we call it quadratic. The next thing we can look at here is the maximum number of turns being 1. Okay, all you need to do there is take your degrees and subtract 1 from that. But make sure, again, with a quadratic, we know we should be expecting a U shape here. The leading coefficient then is what? All right, and we know it's -2 because this is in that form that we discussed where it's a times x minus h squared plus k, what we call the vertex or standard form. Any concerns with that? Now, with the leading coefficient being negative, what does that mean to me again? There's a reflection, right? You could also talk about the stretch there, right? There's going to be a stretch of a factor of 2, right? Since 2 is bigger than 1. But one of the main things we want to take that from is the reflection. With that said, you could also then state the end behavior. Now, we use end behavior usually for other graphs, but it's a good place to see that it still holds true for quadratics as well. Right? So as we look at the left-hand side, we would say x approaches negative infinity. What's the reflection tell me my graph's going to do? All right, so quadratic, right? The parent function, if we go back to the parent function, looks like this, right? What is this function going to do? What did we just say we have? A reflection, right? So what do we need to do to that U shape? Turn it downwards, right? So as I go do this, it's going to look something like this now, where both ends are going negative infinity or falling, right? Both ends are falling. Okay. Now remember here, you could say left hand or right hand, rise or fall. Those are words that I feel will help kind of satisfy what we're working with. We do not use increasing and decreasing because that's reserved for the average rate of change. Okay. As we look at this though, what's a point that we can get from our function by just looking at it that is important with quadratics? All right. The vertex is definitely one of the things that we want to get, right? That being in this form then is what's going to help us, right? We got the leading coefficient already. So the next thing to do is say, hey, how does the -3 and 5 help me? Well, that's where the vertex comes in, right? The horizontal shift and vertical shift is going to be the vertex or turning point of our graph. That's the nice thing about quadratics. We can get the turning point through completing the square, right? So that's where we'll go down here. Now, what do we have to do with the 3 though? All right. Change the sign, though, is the key, right? So we have our vertex, and that's actually a point we can go plot right off the bat. 3, 5, and we got 1 point to our graph. Now from there, our graph, remember, is going downwards. If you wanted to, you can use transformations to graph it. You have everything you need to. Just remember that you have that stretch factor of 2. So that's where those points would come from, right? Instead of 1 squared being 1, I went down 2 because it's 2 times 1. Instead of 2 squared being 4, I went down 8 because it's 2 times 4. Now, what other points, though, should we find that could also help us fill in? Find our intercepts, right? That's where our intercepts come in here, where we could say, hey, let's go find our y-intercept. And what we're going to find there is going to be what, negative 13? Yeah. So it's kind of out of the range of what we would like to graph, but we have it. Right? The x-intercepts are a little bit more work, though, because we're setting the whole function equal to 0. But remember here, when I have a quadratic, how should I solve this one when it's in that standard / vertex form? What would someone do here when we try to solve this one? What are you trying to use, though? You're getting the squared part by itself, right? So that we can use what? A square root, right? The whole point there is understand when you're in this form, that square root is going to be our focus. Make sure that we see that that's what we want to use. Now, does that square root work out nicely here? No, right? So understand that your 0 is going to be irrational. Now, make sure you see as well, though, that as we deal with that, it's definitely something that we can use, though, as far as kind of approximating what we're working with. So it is helpful. I'm going to shrink down and zoom in real quick. Make sure you see here as you finish solving this that you need to put plus or minus. That is definitely something we want to have with this process. Now, what happens here is we can't do anything with the 5 halves. So what we do is called simplification. We haven't gone over it a lot, but we don't want the square root in the denominator. So what we're going to do is multiply the 2 on top and bottom, right? What that's going to give us is plus or minus the square root of 10 over 4. What do we like about one of those numbers now? It's a perfect square. So make sure you see that I just multiply top and bottom by 2. That makes it a perfect square. And all of a sudden now we have plus or minus the square root of 10 all over. Oops, I forgot something here, y'all. That's x minus 3, by the way. All over 2. That's what we call rationalization. That's just me getting the radical out of the denominator. We might have briefly talked about at the beginning of the semester, but this would be a situation where it comes up. Okay. Now remember, we still have that 3, so we need to add, excuse me, we got to add the 3 to both sides. And there will be our 2 solutions. Now, make sure you remember the 3 is helpful here, because when we talked about quadratics, we talked about that axis of symmetry, right? The 3 is my axis of symmetry. So to see 3 plus or minus something should agree with what we just saw, right? Go a little to the right, go a little to the left, and you have your x-intercepts. Okay. With that said, though, make sure you go in and whatever you're comfortable with to get those points plotted out. I will say, though, knowing your transformations here would be more helpful than trying to use those x-intercepts, okay? Is there any questions or concerns I can help clear up there? Now, if you're still uncertain where I got these points from, remember that's where I said build a chart. You center your chart or your function around the vertex. The values you plug in from there should be right before and right after the vertex. Plug in those values and you'll get the 5 points the 4 extra points I plugged. Okay. That takes more time, though, than just remembering double the distance going downwards. I don't think I'm missing anything, right? We found our z-intercepts. We found the end behavior. Now, for the quadratic, though, on the test, remember, I'm not necessarily going to ask all of that information, right? I'm going to ask you, like, hey, what's the vertex? Is the vertex a minimum or maximum value, right? So for this one here, what would you say? the max, right? And remember there, all you have to do is go back to the fact that it's a reflection. That's the agreement that it's going to be a maximum value. Our range then would be negative infinity up to that value of 5. Okay. Those are things to be prepared for. Anything else so I can clear for somebody here as far as that process? Now, hopefully some of you caught on. I went and copied stuff from the other problems. As you deal with polynomials, whether you're asked to or not, if it just says graph, you need to list these things, right? This information is very important. Anytime we approach working with a polynomial, this is something that we need to look at. All right. So as we deal with this, we want to make sure that we're prepared to handle not just with quadratics or cubics, but any polynomial. What terms are we highlighting with this one, though, to help us? Because it's cubic, right? So we have to take the terms into account. So leading coefficient. I don't know what's going on. Sorry. Remember, since it's in that general form, right, we have terms involved being added and subtracted one another. We want to focus on the leading term and the constant term. From there, remember that exponent is what tells me the degree. So, hey, we're working with the degree 3 polynomial, or hence why I called it cubic. Maximum numbers is 1 less as far as number of terms. And then the leading coefficient is 2. All right. What changes with the in behavior with this one, though, when I go from the quadratic to the cubic? They need to be different, though, is the key, right? So make sure you remember cubics, these two things are going to be different, right? So the key is do I have a reflection to change anything? So since there's no reflection, then we go back to the basic x cubed graph, right? So that means this side is going to fall and the right side is going to rise. So the left hand falls, the right hand rises. Now make sure you're writing in falls and rise there too, because I know the homework uses this notation, right? But on the test, like I said, fall and rise covers it as well, okay? I'm not against that notation being used, but I know on the final exam, they use fall and rise, which makes that, it's one of those things that bothers me, right? But that's why I make sure to do both in class. So you're good for the homework, but you also know that I've been saying fall and rise as much as I put this information down. One thing to make sure to highlight, what is special about these two, right? Well, they're different. We know they're supposed to be different because this was odd, okay? Anytime your degree is odd, they're different. And if you ever get stuck, again, go back to the basic function of x cubed to help us with that, okay? Where can I go now? Right. The nice thing about the standard form, right? Not standard form, sorry, general form is that g of 0 is what? 9, right? That's where we could jump straight to it, okay? Having a polynomial in standard form is really nice for all this first part, right? Get a quick understanding of what I'm working with. Now, where does this become a bit more of a burden? Well, guess what? The next step is to go find, again, those x-intercepts. Right, so we need to find the zeros of the function and pull out all the real values that we get. Okay. Now, when we do this one, what do we have to recognize? What would someone try to do here to solve this? How many terms does it have? 4. So try factoring by grouping, right? But is factoring by grouping going to work? No, you could write it out if you need to, but just make sure you go quickly, right? Does 2 and 11 work together? No. 12 and 9 is definitely not going to give us 2 and 11 though, right? I can pull a 3 out of that one, so I'm not going to get the same groups. You don't actually have to go through the whole process of grouping to see that. Just check the coefficients and see what happens real quick, okay? With that said, then, that means I have to use what? The synthetic division, right? Synthetic division is force. With that said, though, what numbers do I use? All All right, so I need to list out though that the values that those give me, right? Again, we went back to the top. To get the possible values that work with synthetic division, I go right back to where we started. The leading term, specifically the leading coefficient, and the constant term. So we'll say, hey, the possible rational zeros here, these are just all possible numbers that could work, are going to be the factors that are formed with the 9 and the 2. Now, which one goes in the numerator? The 9, right? And does anybody remember what I said to do to remind you if you forget? Make up a problem. Like 2x minus 5 equal to 0. Isn't that terms? Right? It's nice to go because it's linear, right? Well, in order to solve, we want to get x by itself. That doesn't necessarily change, but this will help you see that, hey, guess what? That constant term, it goes where? Where did the 5 end up? On top, right? That's my numerator. So that means that, hey, the 9 is going to be our primary focus. So we'll put plus or minus 1, plus or minus 3, plus or minus 9. Right? That'll give me the possible integers that could work. However, we don't want to forget the 2, right? So what do I need to do to all these? Well, I need to take each of them and say, hey, all of these could also be over the 2. Does that mean we're going to use the fractions? No, right? That makes you go back to your quiz. As I mentioned, for those you came in after I started class, the quiz was due this morning. It should have been done during class time yesterday. It was 3 problems. It really shouldn't have taken you the whole class time. So there was no excuse not to have it done for class today. You have until 3 o'clock to turn it in today, though. So for those of you who did not turn that quiz in, you have until 3 o'clock to get it turned in. All right. And if the Canvas is not letting you upload it, once again, we upload PDFs. You have to scan your work, not take a picture of it. So make sure you remember that too. Okay. With that said, though, does this list represent all the zeros of my function? So does that mean any of them are a 0? Yeah. Not at all, right? Make sure you understand that these are possibles. That means none of these could work, right? None of these could work. That's where the synthetic division comes in with the guess and check, right? So we want to take these values and we want to take our function and say, hey, let's go do our guess and check now. So let's go over here and do some synthetic division. All right, so what number does someone want to start with? All right, so just throwing it in there, right? I'm choosing to start with 3. The 2, the negative 11, the 12, and 9 came from my function. That represents my original function g of x right now. Okay, we could go through the synthetic division now. Had you already done it? No. With all that done, though, what is it that needs to stand out to us? 0, right? Hopefully what you catch on, that's why I put the box there, right? I put the box there to say, hey, this is the whole focus of doing this. When I go in there, I can now conclude that g of 3 equals 0. Isn't that what I'm looking for? Yeah. Now, what changes, though, is the way that we handle moving forward. All right, so that's my quotient. That's where the 2, the negative 5, and negative 3 come in. It went from x cubed down to x squared. And then x squared, x in constant term is what we have from there. What do I put for the factor since 3 worked? X minus 3. We have to remember to change the sign, right? Because the whole idea there is, hey, 3 minus 3 gives us 0, right? Now, I've only found 1 0, right? The degrees tell me I should be trying to find 3. So I need to continue forward. What should I do moving forward? What you mean? What are you trying to use to move forward? What piece? because we have choices, right? We can go back and do this again with another number. But again, what piece are we using? We need to be clear on this, right? This is the zero we found, right? That's what we chose to divide by. What is this piece called by technical name? That's my quotient, right? Our choice right now is to either go back to the original function and divide again, or use the quotient to move forward. Which one should I use? We should use the quotient, right? So what we want to do now is say, hey, what would make this equal to 0? Which factoring wise, if you can factor, grouping would still be the approach that I showed in class, right? This is where a table, though, as mentioned, does come in handy, because we're looking at what multiplies to -6 and what adds to -5. What's nice about that? Right, 6 and 1 work though. We actually found that, hey, I can factor this more. Okay. What we're going to find is when we go through that process, whatever you're comfortable with, practice the things you're comfortable with, of course. We should get this here. What needs to stand out to us, though, about this? Right, so there's what we call multiplicity. All right. Now, our whole focus here was trying to find the zeros of the function, right? So we know that for these x values, g of x will be 0. Make sure, though, you're also going through and reminding yourself there is multiplicity. So the zeros we found are going to be the 3. And what's at 2x plus 1 give us? Make sure you see, though, we need to change the sign too, right? It's 1/2. Just make sure you change your sign, -1/2. Now, if you need to, go set it equal to 0 and solve. There's nothing wrong with setting it equal to 0 to solve if you need to actually see where that comes from. But make sure you see that you're going to subtract 1, which is where the negative come from, and divide by 2, which is why it's 1/2. Okay. But when I look at that, make sure, again, you also are noting that the 3 occurred 2 times. The -1/2 only occurred 1 time, but altogether, that's still the 3 I was trying to find. Okay, so we still found all of the values we're looking for. And if we compare back to over here, we could see both the 3 and the 1/2 were on that list. So we're good to go. Now, the problem is you had to do the quotient to get multiplicity. If you didn't use the quotient, you would have only found that 3 and -1/2 working. You would have went through every possible value there. So we have to be careful to understand the importance of using the quotient as you go forward, right? Make sure you're highlighting that. That is very important. Now, are we done with this problem? Yeah, the whole point of doing this is graphing it, right? So what we need to do is take all these things and go get a graph going. So with that said, oops, I need my bigger one, sorry. What did we say the y-intercept was? 0, 9. We said +3, right? And -1/2 are x-intercepts. Okay. So we have those points there. What else did we say that we can use help us graph? Because as we go over here, we've used these 2 pieces here. Oops. All right, we got those pieces in place. What else did we describe here, though, that we need to use? The end behavior, right? We could actually bring this over now and say, hey, I got a general idea. It's not perfect. It's just a quick idea of what's going on, right? Help us with this. So as I deal with this graph, just a quick idea here is that, hey, I know I'm going to need to do this through those points. All right. Now, this is where multiplicity comes in and fills in the gap. How many times did we see negative 1/2 occur? Right, and that's why we list it down here, right? So when I go to draw this, I need to go straight through it like as if it was behaving like linear. It's not linear, but since it only occurs one time, hey, I'm going to cut straight through it. Well, with that said, don't we need to get all the way up here? Turn back down. Now, what happens at 3 though? How many times did the 3 occur? Twice. So as I come back down to this, I need to bounce off of that and turn back up to follow, as I was showing here already, this part of my graph. Now, if I zoom in here, what did I say it looks like? Similar to? It's like a quadratic, hence why we bounce off it the way we do, right? But overall, is my graph perfect? No, we would have to plug in a lot more points to get more accurate. But I also mentioned too that something like this here, that highest point here, and even this point here can be confirmed using the average rate of change, right? But that's, you need more mathematical language to do that. So we're limited on what we can do now. So at this point, understand it's sketching a graph that we're focused on. Okay. The things that I'm going to look at to make sure you use are right here when it comes to graph. Any questions with this one before we move forward? All right, what's going on with this one? It's a little bit different then. It's already in factored form, right? Do I have to go through the synthetic division with this one? No, right? It's already done that work for me. So, hey, I got a lot done. Now, we have to be careful here, though, because as I go through this, then at some point, I'm going to find, not G, sorry, we're on H now, our H of 0. But the nice thing is H of X equal to 0 is kind of already given to me, right? And this might be a good place to state it right away. Just make sure, again, when you state your zeros, make sure you state your multiplicity, right? So what does this first factor give us as far as the 0 is concerned? Not 1. We have to change the sign, right? So X plus 1. No. What's the 0 first, right? The first one gives us negative 1. This one, though, does give us positive 1. And this one gives us what? Positive 5. Now we do need, again, we do need to talk about the multiplicity though. So hopefully you see here that the only one with an exponent is the X minus 1, and the exponent is 2. The others do not have exponents, so they only occur one time. What is the degree of this polynomial then? Why is the degree of the polynomial 4, y'all? Where do we get that from? All right, add them up. As we can see confirmation-wise here, we said the degree was 3, and look at that. The multiplicity adds up to that exact value. So we need to make sure to use the same thing here to say, hey, the number of factors I have, that will give me my degrees, right? Which means the maximum number of turns here is going to be 1 less than that. What's the leading coefficient then?
-1/9.
Are we allowed to use that though? What do we need to look at to confirm? Well, make sure you see here, is there anything in front of those X's? All right, so that's your confirmation that it's in that X minus K form for each of our factors. So we know the 1/9 is our leading coefficient. And as you were saying, I think you said there is a reflection. Now, with that in mind, the next step would be the end behavior. Should both ends be different or the same for this one? The same, right? They're the same because 4 is what? Is even, right? Now, with the reflection, it means they're both going where? All right. They're both falling. All right. We see that here. They're both the same and they're both falling. Okay. Now, the only last thing here that we would have would be the y-intercept. It's going to be 5/9. Make sure you plug in 0 and get that. I'm not going to go into the full details of that process. Makes you see 0 plus 1 is 1, 0 minus 1 is -1, 0 minus 5 is -5, right? Be careful though that you see that you had 4 negatives in total. That's why the last result's positive. Okay. With that said though, what else do I need to graph? Is there anything else I need? No, right? We have all our intercepts. We have our in behavior. So let's go graph this. In fact, I could probably fit it right here.
I have a question.
Yep.
How do you get weight back?
Where do I get that from? Right? No, from the degree. All right, remember for that, you always take your degree and you subtract 1. Those are closely related. The best way I would say this, always go back to a quadratic, right? It's x squared, it turns 1s. And it's going to be that way for any power above as you go, just 1 less than the degree. So with that said, then I can go in here and start plotting my points that I found. We have -1, +1, +5. And the fun one here is going to be with the 5/9, which is just a touch above a half. Right? Remember, again, as I stated, we're just sketching. What's next, though? We plot our intercepts. What should I go sketch out? And behavior. I get an idea where we're at to start, right? The ends better fall. The next step then is to take into consideration my multiplicity, right? What's the multiplicity of -1? Just once, right? So, hey, guess what? Let's just cross through that real quick. Right? Well, as I cross through that, I'm going to have to go up and come back down. Through 5/9, but as I approach the +1, what's the multiplicity of the +1? 2, right? So that means, hey, guess what? I need to bounce off of that. Now, does the 5 agree with the fact that I'm above the x-axis and I want to end below? All right. So the multiplicity of 5, does it tell me to cross through it? It does, right? Because it only occurs 1 time. So it's okay that we're above, right? Because I'm going to go up and cross right back through. Now, with that said, one thing we haven't really done is I've been focused more on getting to the pieces of the polynomials. Is remember, you could always check if a function is even or odd. Is this function even or odd? Is it even? Is this side of the graph exactly the same as this side? No, right? So there's no symmetry. Is this the same exact thing as what we see up here? No, right? So understand there's no symmetry here, right? A lot of times you're not going to have symmetry. So know that, like, if you were going through the homework, as far as the Pearson stuff is concerned, that might be one of the questions they throw in there. Hey, don't forget to check symmetry. That's always a good thing to check for. But here, that would be a pain to have to go through and check with something that's already in factored form. Something that could stand out to us is, hey, I use -1, +1, but then I got this -5. That throws off the symmetry. If you had x plus 5 as well, then we can start having that conversation, right? Here, what terms do I have that mess it up, right? Well, I have 1 odd and 1 even. Right there, you know that, hey, I'm not even going to bother checking for symmetry. It's it's neither symmetrical to the origin or the y-axis. Okay, so keep that in mind. Is there anything I further clear up with this one, though? All right, so the next one then looked like this. Hopefully what you're seeing here, though, it's x to the 4th again, so I'm copying down everything we just saw. The big difference here is no reflection, right? My leading coefficient is +1, so make sure you see that as we go through that. Instead of falling on both sides will rise, okay? This one is not factored for, so we are going to have to deal with that. But one thing to make sure you see here is that since it's in that general form, we know our y-intercept. There is no constant term, so your y-intercept is the 0. Okay, so keep that in mind that the origin is our y-intercept. But at the same time, guess what? You just found an x-intercept too, right? Origin is one of those special points. Now, you have to be careful here, though. When it comes to dealing with this function and solving, what is going on that I have to be aware of that we don't run into all the time? There's no constant term. Why is there no constant term? What do all the terms have? An x. So what can I do to deal with that? We can factor an x out. So this is one area where you're not going to run into it all the time, but make sure you always factor out your greatest common factor. Because at that point, you'll have that confirmation that, hey, we already stated that this was one of our zeros, right? And then this piece here is going to be what we need to focus on moving forward. That becomes our focus. Okay. Now what you're going to find there, of course, is that factoring by grouping doesn't work, right? 28 doesn't go into 48, so I'll never get 7. So we'll have to go through that whole process that we just discussed of listing out our possible rational zeros and finding them. Are we good though with what I did with the x and pulled it out? Do we understand where x equals 0 is coming from? All right. And make sure you see here, this is the quotient then that's left over. Once you divide out the x, this is our quotient, right? Now, what we have to be careful of, remember, this is not our original function. So anything I talk about here, all I care about is a remainder equal to what number? That's all I care about, nothing else, right? A remainder equal to 0. So let's list out those possible rational zeros. This one's going to be a little bit more involved. Now, this one may have a lot more going on here. Does that mean, again, I'm going to use every single one of these? No, this is just all the ones that are possible. Okay, please keep that in mind. I'm not saying all of these are going to work. In fact, only 3 of them could possibly work. And none of them are guaranteed to work, right? So as I go through this, so should I try 48 first? No, try to avoid stuff like that, right? Let's just pick 3 since that's been the pattern lately. Let's see what happens. Hopefully I didn't pick the same number multiple times, right? But as we go through this, what's going to be the issue someone sees here already? It's never going to approach 0, right? Does everyone see that? Why is it always going to get bigger? What can I notice from the beginning that I should watch for when I drop down to deal with this synthetic division? What never shows up here? No negatives, right? There's no subtraction. If all you have is positive numbers, it's only going to get bigger, right? So that means then, should I have ever tried positive 3? No, what should I have tried instead? Negative 3. So let's see what happens. With that said, make sure you go through your list though and kind of remind yourself like, hey, don't worry about any of these positive results because none of the positive numbers will work here, right? So let's try negative 3 and then we can move forward. And look at that. The 3 still worked. Just had to be negative.
No 16?
Yes.
Obviously.
Now keep in mind, like as far as we looked at our function, that gives us x times x plus 3. And then we'll have x squared plus 4x plus 16 all that equal to 0. So as we list out what we're finding here, we got 0 already. So we have that in place now. We have -3 now, which we just found through synthetic division, okay? But we still need to go forward because we need 2 more. So let's have 4 in total. Now, what factors of 16, though, add to 4? One and 16 doesn't work, 2 and 8 doesn't work, 4 and 4 doesn't work, right? So what do I need to use here? Can't factor a quadratic. We can use the quadratic formula, right? Well, let's do something different. What am I doing?
Completing the square.
Right. Now, if you use quadratic formula, we better get the same answer, right? I like completing the square though, because it gets me straight to the point, right? Quadratic formula though, you should get some of the same stuff when we're done. Just make sure to simplify. Okay. Make sure you see here though, what number should stand out to me right now?
It's a negative.
That it's a negative. I told us the graph right now, right? What is this -12 going to give me that the quadratic formula would show as well that I do not need to worry about? An imaginary number. If you need to write it out, make sure you write it out to see that. Right? This would give me x plus 2 plus or minus the square root of, oops, equals plus or minus the square root of 12i. Done. Move forward. Right? The main thing that you should write to yourself here is not real. So the only x-intercepts I'm going to have on my graph are these two. Okay. Now the quadratic formula, if you choose to use it though, make sure you see here, you should get x equal to -2 plus or minus 2 squared to 3i when you're done simplifying. All right. Factors of 12 are 4 and 3. The square root of 4 being the 2 that I pulled out in front. Okay. Now, remember here, though, I circled 0 and -3 because that becomes our focus, right? Now we have all that we need to talk about this graph. So when we talk about this, we'd have 0, 3, and both of their multiplicities was 1, okay? Any questions that I can further clear for somebody? So we're okay. Well, then graphing wise, we're going to go start plotting these points. We'll plot 0, 0, 3, 0. There's our points. We know that from here, we should be going upwards, right? Now, what you're going to find here is as far as dealing with the complex solutions, our graph technically will look something like this from our perspective. That's really the best we can do. Is it quadratic though? It's x to the 4th. It's not quadratic, right? So it's not a parabola. What you find here is whenever you have complex solutions, your graph's going to do this somewhere. Something along those lines, right? And the way that we know that, again, goes back to looking at the average rate of change. Now, did I tell us to do the average rate of changes now? No, but the way that find stuff like that is through the average rate of change. Keep that in mind, okay? We're not going that far. So understand that if you just put a U shape here, going through the points like you're supposed to, then that's the best we can do. We can fill in that other stuff as we get better equipped. That's the best we can do. So keep in mind as I show you this, though, that's what a complex number kind of does to our graph, right? It has something going on. We have to use other ways to get there, okay? Any questions with that? Yeah, I could clear for somebody. All right, so like I said, hopefully what you see here is just making sure we go through our polynomials. I try to cover several of the different ways that they can be given to us, right? Whether you have a quadratic in vertex form, or you have a polynomial that's in general versus factored form, right? Make sure you see for all of them, the degrees, the maximum number of terms, leading coefficient in behavior is definitely something we want to have in place. With that, Y-intercepts, X-intercepts are very important. Okay, so keep that in mind as you work through some of these. All right. Now, what did I say about this? It needs to be uploaded by 3 p.m. today, right? You had, as I said, that's what we should have been doing in class yesterday. If you needed help with it, guess where I was? In the Digital Learning Center, right? I sent out, I don't know if all of you saw it, but my appointment took like a fraction of the time it was supposed to. So I was over in the Digital Learning Center and I made sure to apply on there. So I saw a couple of you on campus around that time, right? So but I know most of you got my announcement though, because guess where I was at 10:30? At the door waiting, just to make sure, right? So keep that in mind, get it done. Moving forward, I probably won't be doing the long division again, so this is our opportunity to review it and make sure that we're comfortable for the test with the problem that we have on the test. Okay, so make sure we get done. Any questions as we head out? All right, then have a good day and I will see you tomorrow.
Test again?